project goal is to have a robot arm pick up an object and place it in a receptacle. Both the object and the receptacle can vary in color, shape, and size. The only restraint should be with the arm hardware: how much it can lift, how far it can reach, and the object size. There are several steps we had to do in order for our project to come to life. To accomplish these tasks, we built 3 ROS nodes that communicate with each other to get the job done. The first of these nodes is our histogram. The histogram's job is to find both the object we're picking up and the receptacle. Here's a visualization of that in action.
The histogram node is given 2 images, one of the object and one of the receptacle. The Kinect camera also publishes 2 messages or histogram takes advantage of. One is the image shown here. This image has no depth attributes, so even though we are able to find the objects in these images, we have to map the object point to the second message from the Kinect. The point cloud message has the depth information of the image, and mapping between the two is how we get the location of our objects in 3-dimensional space. Since the object can look different than the image we're told it to look for due to glare, distance, and a variety of other factors, we can't just map the pixels of our image to the picture of the object. So what we've done is perform a convolution on our image from the Kinect to find the collection of pixels that are most like our objects. So here are the 2 convolution images. You can see these disks of object-like pixels. We then take the pixel that is most object-like and translate that to a pixel in 3D coordinates in our camera's frame of reference. The next step is to take this 3D coordinate in the camera reference frame and change that 3D coordinate to the robot arm frame. Our locator node uses the TF package to accomplish this. The TF package assists us by using matrix multiplication to change from camera coordinates to arm coordinates. Now we have the location of the objects with respect to the arm, so it's time to pick them up. Our arm controller node is in charge of making these movements. This node has 2 states, one where it's trying to pick up the ball, and the other one is trying to drop the object in the receptacle. In both cases, we have to plan the motion of our arm to get these points received from the locator. After acquiring the ball, we change states and plan the route to the receptacle before dropping it. The robot will change between these 2 states indefinitely until we power down.